So yeah, hello everyone. Welcome to the session. Thanks everyone for being present here. Today I would talk about the power of mocking APIs. And in this session, we would explore how this technique of mocking APIs can help us test our systems in isolation. Before I start the talk, a little bit about myself. So who am I? I'm Shivani Gaba. I'm originally from India. And currently, I'm working in Hamburg here as a lead QA engineer in Newark SE, which is basically a parent company of Zing, a social networking platform. And I'm fond of collaborations and pairing up. And I'm always up for discussions on Zing, Twitter, emails, or even on beer tables. So do catch me later on also. Yeah, I'm a tester, right? I'm a QA engineer. So I love testing. You would always see this magic charm in my eyes when I talk about testing, or we have discussions about it, or when I'm even doing testing. So I'm very happy when I do stuff like that. But there are also times when testing makes me like this, like super irritated and frustrated and crazy and about to almost bang my head in front of the computer. And do you know why? Like, what makes me do like this? This happens when I'm trying to test, also together with my developers and my team, some complicated systems, which has multiple number of APIs involved. So there are systems which have dependencies, and they're so decoupled with each other that it's hard to test them, right? Or sometimes when we are about to reproduce some production bug in our test environments, which is coming due to the APIs that we depend upon, but because we don't have control, it's hard to reproduce such bugs also. So these kind of situations really, they make me irritated. And I thought that it would be interesting if I tell you my story, if I share my experience with you, tell you about the products that I've tested, tell you about what problems we faced and what solutions we found for them. But then I thought that it would be even more interesting if we explore something together. An application basically that we all could get familiar with easily, try to understand its architecture, see what, try to test it together, see where we are stuck, and how the mocking would help us here to solve these kind of problems. The application we would test today, explore today is a weather check application. It's basically a simple application that I've created for the purpose of demonstration of this talk. At the end of the talk, I would also share the source code of this application, as well as the mocks that we would create, so that you can also explore it later. So let's start. Are you all excited to explore this application? Give me a yay. Yay. Hey, so many people. My hey is louder than all of you together. Yay. Yay. Cool. This is going to be fun now. So let's have a quick look to the application itself. See the screen, right? So this is the application. Basically, let me enter our city, right, where we are, Hamburg. Is the internet not working? It does. OK, sorry. I think the internet is a bit slow here. So on the this is the application that we are working. We'll explore today. On the left-hand side, you could see that we have some generic information like icon, which displays what kind of weather it is, and what's the degree temperature, and what's the date. And on the right-hand side, there are some specific details like what's the minimum maximum temperature, what is the wind speed, humidity, sunshine, sunset, description, and geocoordinates, and etc. Right? So it's basically a weather report that we have here. So now let's try to test it, and I hope the internet works fine now. Otherwise, the response is a bit slow. So let me enter my favorite city. So my Chicago, right? It's putting it up properly, right? Maybe one of you could tell me a place to enter. your favorite place, maybe. Paris? Okay, so we have Paris temperature, Paris weather here, which looks good. Now let's try to test some invalid case. Maybe someone could tell me the favorite sports. Legoland. So it says it cannot find the city, which is correct because it's an invalid term that we wanted to enter. Now maybe let me try some symbols. So it also says that it's invalid. I did not enter any city, which is fine. Let me try some numbers. So it seems like it's giving me the weather of the place where this postal code belongs to, which is Hamburg, which the place like my postal code, which also seems fine, right? But now let me test. So maybe I want to see a thunderstorm here. How do I check that? So either I have to find a place where there's a thunderstorm right now, which would be super hard, or I pray for thunderstorm here in Hamburg, for which you would kill me. Or what do I do here? So we are stuck, kind of, right? So let's see, first of all, what's the problem here. Let me enter Hamburg. So what is happening here is basically when I click on get weather, right, an API request is made to this particular API, which is an open weather API. It's a third-party API that I've used. And when a request is made, a response like this is returned for this API. And this response is then manipulated and some business rules are applied, and it's displayed here on the front end here, right? So that's what is basically happening. And to test a lot of cases, for example, the thunderstorm case, right? Or what if I want to test that this API, it's giving me an invalid response, or this API is, it's not available itself, the service is down, right? So how is my application responding to that? That's super hard to test right now in the current setup. So let's see what's the problem here and how we can find solution for all these kind of things. So what we saw right now was that there's a client basically, which is a weather app, the front end part, and it makes a API request to the server, which was the open weather server, and a response is given by the open weather server and manipulated and displayed on the application, right? That's the part. And to test a lot of cases, what we don't have is a control over this part for the server and the API response that we are getting. And what we want here is to control this API to test these cases. And how do we do that? Is basically, this is the current setup, right? The server client talking to a server. So we would break the connection between this, and we would create a mock server. A mock server means the server that we would set up, which would be under our control. And then we would have a stubbed response. So basically, this would be a response that we would set up, and we can make it any response that we want to. For example, a valid response, an invalid response, or even some error cases. So all of this remains under our control itself. So the tool that I would use today to create the server itself and for stubbing the response is Wiremock. And why I've chosen Wiremock is basically it's super easy to set up and configure, which we would just see in a while. It offers various features, which we would explore some of them. It's possible both in standalone and in embedded system. We would explore the standalone version today. And it has very active community support. So no matter what problem you're stuck with, you'll always find people who can help you out here. But as a general disclaimer, I'm a fan of approach over tools. So what I want you to take away from this talk is the technique of mocking and how stubbing responses can help us. And tools, we can choose whatever suits our project, our needs, and the language and everything, right? So let's have a quick look of how this technique can help us remove this kind of dependency. So first, what we need to do, we want to set up the server, right? So I have this project where the only thing that I need to set up do to set up the server is to add this dependency of Wiremock, and then this jar file that you see here. And now I would run this jar file. And we can see here that the server is set up on 8080 port by default. So that's super simple, right? So the server is set up now. The second step now is to create the response that we want to put in. So what do we do here basically? Let me just open this function. So I would say here, I would stub for getting this basically endpoint, which is the Hamburg endpoint right now. And I would have a response of, we want with status, one second. With status code 200, and we would put a body file, right? Let's call it currentweather.json. And what we want to put right now in response, let's try the same response first, what the actual server is giving us. So let me copy paste this one. I'm live coding, God bless me. Okay, so we have this current weather JSON. That is basically right now the same response that the server that the actual server gives us. So let me run this. Works fine. Let's quickly check if this actually happened. So let me open. It's readable, right? Or should I change the font size? And we have Hamburg. So I put localhost 8080 and Hamburg here, right? So now it's the response is set up, and it's the same response that we have put in ourselves now. So 2 steps are done. We have created the mock server, we have the response set up. Now the step left is that our application, it talks not to the original server, but to the mock server. And for that, this is the code of the application. And I have added here a drop-down, basically, for easiness, that I can switch between the actual server and the mock server. And for demonstration purpose, I've added it easily here, so we don't need to go back to that code again. So here is the drop-down, actual server and mock server. Let's see if it works. So for actual server, let me close this. Right? So the request is made to the Open Weather API, which is correct. And if I put mock server now, the second request is made. Now this is to the localhost API. So now you can see that my application, it can talk to both mock server and the real server, wherever we want to talk it to. And connecting it to the mock server, we can put any response that we want. And now we are not dependent upon the actual one anymore. So we have removed the dependency, and our application can be tested in isolation now. And now I would like to go over with you with different scenarios where this technique could help us. Scenario number 1, difficult to reproduce scenarios. So we were discussing about checking thunderstorm weather and sunny weather, right? A lot of times things like this happens to us, that they're difficult to reproduce cases, or it's like a lot of configuration is needed beforehand, some databases changes, something to manipulate, and so on, which is actually hard to do with the real systems. And here mocking can help us. So let's try with the thunderstorm weather, for example, which was hard to test earlier. So what I would do here is basically, let me close this. Oh, I by mistake closed this. So basically, we have this function earlier, which was testing the actual weather, right? Now let me just try with some different weather. Let's say different weather.json, and I would copy paste this file here. Call it different weather.json. And now we can change anything we want. For example, trust me, I know the code is 800 for displaying thunderstorm. And let's say thunderstorm weather, right? Let's put thunderstorm. So now if I run this, it should put the different response now I have. And now if we check here, oh, wait, sorry, 200 ID. You shouldn't have trusted me, question me. Yeah, putting this response there. And now if we get Hamburg, now it's thunderstorm. So you could see, right, I could put anything that I want to, an image of a sun, a thunderstorm weather. So these kind of complicated cases, which were not easy to test with real server, we have easily tested with the mock server, where we have put the response that we want to test. And in similar way, what we can do is basically we can set any body response, not only changing icons or thunderstorm, but anything in the response that we want. We can test complicated cases, and we can test some edge cases scenarios also. Scenario number 2, invalid responses. Bugs, right? The thing that we all want to find before we even deploy our code to production. But how do we find these kind of things if the API that we are depending upon is having bugs, and we want to test our system, how they behave for that? So it's complicated to test, right? But again, we have the technique of mocks with us. So we can stub any response here, and we can test this. And from now on, for all other scenarios, I have pre-recorded the videos, so we can see them. And for my favorite city, Chicago, so I would play the video, and we'll walk through them together. So for testing invalid response, this is the same code, right? It's 200, and then invalid body.json. And now I would open the JSON file. And in this JSON file, this is right now valid, and we would make it invalid together. So I would change the temperature minimum and maximum to data types of strings instead of integers. So now they are strings, A, B, C, D, and E, F, G, H. And I would even remove some, for example, sunset and sunset, which are mandatory fields. I have removed them. So now this file is invalid for us. And if I run this function now, I go there, check. Now you can see that the changes are reflected. It's A, B, C, D, E, F, G, H, and there's no sunset and sunrise. So now we have an invalid response. And if I go here, change to mock server, Chicago, and you can see that there are bugs on our system. There's NAN, and there is invalid IST, which is not good, because the systems, the API that returned bug, our system was not able to handle it correctly. And with the help of stubbing these kind of techniques, we can easily check these kind of bugs and find it beforehand. And similar kind of ideas to test is basically in the body, like I removed some fields and I changed the data types. We can even add some extra fields. We can check for correct format, like instead of JSON, we can text for XMLs or some other formats. And we can check for different headers, like we can remove some headers, see how our system is responding. We can put some invalid headers, and so on. Scenario number 3, API responsiveness. "30 seconds I was not responsive," and it made you all curious. Who would wait for a weather report for a minute, right? It's 2022. We all get so impatient so easily. And that is also important for our systems then, to test that what happens when there's a slow response from the systems that we depend upon. How are our systems handling it? And again, we have the technique from stubbing responses to do it. And let's see how we do it. So basically, this is the same function with 200 status code and the correct JSON, and I would add a fixed delay of 9,000 milliseconds here. And if I run the function now, its function is run now, and we see the stub, and you could see on the top it's still loading. So that means there's a delay right now in the response. And if I choose mock server, Chicago, enter, and you can see on the left side there's a pending that it's loading correctly, and on the API response also it's showing pending in the console, and as soon as the request is successful, it is loading correctly. So it's a good user experience that we are giving a correct indication to the user that your request is in progress and we are working on it. So this thing is also important for us to test, and our technique has helped us here. Otherwise, it's how would we have tested it with the real system? We cannot go to the system to say, hey, please shut down or please slow down your API so we can test it. And yeah, so we can test scenarios like this. Am I too fast, too slow, good speed? All good? Cool. Scenario number 4, errors and faults. So it's also important for us to check what is happening when the systems that we depend upon are not working fine, like they are returning, they're unavailable, or they are having ISC server errors, or some kind of connection reset problems, and so on. So let's see how we do that. This function, I would now make it return not 200, but rather 500, which is internal server error code. And I would remove the JSON body file. It's not needed. And now I run the function. So now it would set up, instead of returning correct, it would set up returning ISC. So function is done. Let's go check. You can see that it's set up correctly. So it's 500 status code error that it's giving. And now I go to mock, select place, and oh, the application has exploded. So basically, our application was not able to handle correctly if there was error in the things that we depend upon. And these kind of cases are also super important for us to have a look before we deploy. And similar ideas to test would be different kind of HTTP status codes, anything like all the server-side errors, even client-side errors, what is happening when there's a bad request, when there are multiple requests, and so on. And also some non-error codes, right? And we can also check faults with the same technique of what happens when there's a connection reset error, when there's a random closure error, and so on. Scenario number 5, API not ready. A lot of time what happens is that our front end is ready, but back end is not, or one team is ready, the another team that we are depending upon is not ready. So there's a lag for it. So how do we test in these kind of scenarios? Should we just wait or tell them to hurry up so we can test our systems? There should be some better way, right? Where you can, where you don't need to wait for the other teams to finish. And let's take an example here. So this is the current application that we explored, right? Let's say we are adding a profile module where we have some image and name, And this team is not ready yet. The API that we would call here are not ready. But we still want to check how it would look in our application here. So what we can do is basically this profile API, which is not ready, we can create mocks for that. And even at an earlier stage, this technique would help us find the API configuration itself. So what could be, how could the body look like, what fields could we have, and so on. And depending upon different things, we can test different cases with the mocks. For example, we could mock for long name, different language names, different kind of image size, different looks, and so on, and see how it looks in our system. So we don't need to wait for this profile API now. And with this, we have seen how the technique of mocks and creating the stub response supports our system and can help us test our system in isolation and in a better way. And when I usually get this question, like, is it only for web apps, right? Because I've shown a demonstration with a web app. So answer is like, no, absolutely no. It's for no matter what your system under test is, if it's a web application, a mobile application, or even some web services, if it depends upon some internal services or some external web services, what we need to do is to identify the ones that we want to get rid of and test ours and mock them. And now our systems are isolated and we can test them independently of other things. So it's valid for all kind of systems under test. And to see a bigger picture, what we saw right now was there was a UI which was talking to a microservice. And if I wanted to test UI, I identified the microservice which was it depending upon, and I tested the UI in isolation. And usually the systems are more complex, right? There are a lot of interfaces, a lot of microservices involved. So if you want to test this microservice, we identify what it's depending upon, and then test the green one in isolation. And another question that appears all the time is, does this replace end-to-end testing? We have seen that this technique helps us test system in isolation. It frees our application. But is it the solution? Is it the ultimatum? And we don't need end-to-end. And I have a simple answer to that. Don't use swords for stitching the clothes. We have needles for that. So right tools should be used for right kind of things. We do need end-to-end test for user scenarios, for testing things. Mock doesn't replace end-to-end test. It helps us test multiple scenarios beforehand and not put every stress on the end-to-end level itself. And with this, I would say, what are the pros and cons of this technique? For pros, I would say we have seen how we can test in isolation. This technique would help us reduce the dependencies, and we can test our part, right? It helps in parallel development. So when the APIs are not ready or one team is not ready, like we saw for the profile API case, so we can develop in parallel. And this technique is quite reliable because we have put what we want and we know what exact response we would get. It's a fast response. We are not calling the actual server, so the delays there, internet connections, everything is removed. And we can test complicated systems and edge cases. We can even test delays like we tested. And it prevents rate limiting, meaning that you do not call your actual server a lot of times, so you are reducing the traffic there, and we are using it in the mock server. And the cons to this approach, basically, I would say it's a headache or it's overhead to maintain the mocks and keeping them up to date all the time. And the complexity increases, especially when there are multiple APIs and a lot of things are increasing. And if your system is getting more complex, this technique also gets more complex. And it's hard to identify which service to mock and which we can use as it is. Other cons, I don't know. If you get to know any, or if you know any, do let me know. I would even add it here. And with this, I would summarize my talk. And so what we learned, let's reflect. We learned about how and why to set up the mock servers. We saw how we could stub different responses. We saw how we test our systems in isolation. We saw different benefits of mocks. And we saw how to check a weather app. So next time you see a weather application, I hope you remember this technique and you remember my talk and me. With this, I would wind up. And as promised, these are the codes. It's all available on GitHub. So I can share this also later in the slide deck. Please feel free to explore around, and we can discuss about different scenarios also. Thank you.